What up, what up? Welcome to Mr. Brown's class where there's no whining, no complaining. Now today we're going to simplify rational expressions, right? Remember, rational expressions are, let's say fractions, okay, with variables on the denominator side. Okay, so simplifying rational expressions, right, with like denominators. Okay, so eventually we're going to add and subtract, but we're kind of going to review from an earlier video, simplifying rational expressions, some of the concepts. Okay, so hopefully this helps you remember some things and makes it stick a little bit better. All right, when we have rational expressions, so look at all these have on the denominator a variable. Right? The denominator can never equal 0. If you put in 3 divided by 0, you're going to get an error message on your calculator. Okay, so you cannot divide by 0. So we first have to figure out what would make the denominator 0. Okay, so in this case, 5 times what, okay, equals 0. Well, 5 times 0 is going to equal 0. So m cannot equal 0 in this case. Now, we can't simplify this one anymore. All right, so all we're doing in this is figuring out what m could not be. Now, let's look at this one. So m plus 1 equals 0. All right, well, we subtract 1 from both sides, and m cannot equal -1 because -1 plus 1 would be 0, right? And we can't have that on the bottom. Now, we also cannot reduce here. Notice how this is just one term, and this is a polynomial, 2 terms. All right, so we cannot, since this is being added together and this is not being added together, this is being multiplied, we can't reduce here. We'll see examples of where we can reduce here in a second. Okay, so if you came across this, you would just leave it as 5m over m plus 1. Okay, here we're going to first say what h cannot be, and then we're going to simplify. Okay, so first, right, 12 times 0 would be 0, so h cannot be 0. Okay, and now since they're one terms, right, it makes it a lot easier to reduce. Okay, so we have an h, 2 h's on top, 1 h on bottom, so this is going to cancel out one of these. So you're going to have h on top. Now we're going to reduce the numbers. Okay, what would go into both 8 and 12? Well, we can divide both by 4, so this would be 2 and 3. So what would be left with would be 2h over 3. And again, that's all you can do. All right, you can't reduce that anymore. We are simplifying it. Now here, in this one, now we have a binomial on top, binomial on bottom. All right, but again, we can't reduce yet. Right, we're going to have to factor, which we looked at in the last video, so we'll also look at it here. Okay, so let's figure out what m cannot be. Right, so m cannot be 3. Okay, because 3 minus 3 would be 0. Okay, so m cannot be 3. Now, we can factor out, what can we factor out at the top? We can factor out a 2. Right, so we'd be left with m minus 3. And on the bottom, we'd be left with m minus 3. Now, we can, since these are exactly the same, we can reduce these. All right, cancel them out. All right, but they have to be exactly the same. So our answer to this is 2, because 2 over 1 equals 2. So this would be your whole answer for this problem. M cannot be 3, and for the simplified down, it's just 2. Let's look at this one. Okay, what would make this 0? All right, well, y plus 2 equals 0. Subtract 2. So y cannot be negative 2. Okay? Now, again, we can't factor out, or we can't just start reducing here, because they're both binomials. So what can we factor out of the top? We can factor out a 4y. So we're left with a y plus 2, right? Because we divide both of these by 4y, right? On the bottom, we're left with y plus 2. These are going to cancel out, right? Because they're exactly the same, right? And so your answer would be 4y, okay? And y cannot equal negative 2. Let me give you one for you to try on your own. Okay, so let's do 6y to the third over 24y, right? Pause it and see if you can answer that. G minus 2, 5g minus 10, okay, and 7d squared plus 21d over d plus 3. Okay, so first, what can y not equal? Y cannot equal 0 in this case, because 24 times 0 is 0. Now, since they're both just monomials, right, we can reduce these. So 6 can go into 24, so this becomes 1, this becomes 4, all right, and then you have more y's on top, right? So this becomes squared, and this cancels out because it cancels out one of these. So your answer is going to be y squared. We don't need to put the 1 here. Okay, over 4. So that would be your answer. Okay, here you have binomials. All right, so first let's figure out, this one's a little bit trickier, figuring out what cannot be 0. Some of you can see it. All right, so 5g minus 10 equals 0. So add 10. All right, because it's subtracting 10. 5g equals 10. Divide by 5. So g cannot be 2. This 5 times 2 is 10. 10 minus 10 is 0. Okay, now let's come down here. So we can't factor out anything from the top, but we can factor out the bottom. So what can we factor out of the bottom? 5, right? So g minus 2 over 5. If we factor out a 5, we're going to get g minus 2. That cancels out. Now, if you cancel out everything on the top, you're left with 1. You have to leave that 1 up there. Okay, so your answer is going to be 1/5. Okay, and g cannot equal 2. All right, what can d not equal here? Negative 3. Negative 3 plus 3 is 0. So d cannot be negative 3. Okay, now we can't do anything with the bottom here, right? But we can factor out a 7d, right, out of the top, the greatest common factor. All right, so we're going to have 7d. We factor out that, we left with d plus 3. And on the bottom, we have d plus 3. Cancel those two out, and so you're left with this as an answer. Bada bing, bada boom. Okay, now we're going to simplify with like denominators. So these are two rational expressions, right? Treat them just like fractions. Okay, so we're subtracting, right? They have common denominators, a to the third, a to the third. Okay, so we can put them together. Okay, just like if it was 1/3 minus, 2/3. Okay, so we do b, we're going to rewrite this as b minus 2b over a to the third, okay, because they have common denominators. Now, what's b minus 2b? Well, remember that there's an imaginary 1 right here, so what's 1 minus 2? 1 minus 2 is negative 1b, but we don't need to put that b there, or the 1 there, sorry. And then it's over a to the third. And we can't simplify this anymore. We know that a cannot be 0 in this case. All right, so you could put that. A cannot be 0. Now this one's a little bit trickier because it looks like, you know, this is not a rational expression. It's just an expression. All right, and then, but negative exponents. So remember what we do with negative exponents, right? Send them to the bottom, right? So this is actually p over q squared, right? Minus, now this is a negative exponent, so this goes up to the top. So 7p over q squared. So actually, it does have a common denominator, right? So we rewrite it as p minus 7p over q squared. Remember that this is an imaginary 1 right here. So 1 minus 7 is negative 6p over q squared. And q cannot equal 0. All right, so we learned a lot today and reviewed a lot. Negative exponents, right? Factoring, what cannot be on the denominator. So there we go. If you like this video, make sure that you subscribe and like below. And remember to be more awesome.